All right, this is going to be for Chemistry A, Lesson 1.03, Matter and Energy. So we're going to discuss what matter and energy are, how they're different, what connection they have with each other. And again, you're going to be using this information to match types of matter, types of energy changes, and physical and chemical changes. So the basic definition of matter is anything that has mass and takes up space or volume. So pretty much anything you can see is matter, but there's also things that are really tiny and you can't see, and that's also considered matter, like atoms. All right, so matter is anything that takes up space and volume. And a good thing for you to know are the different states of matter. And I'm sure you've heard of these before: solid, liquid, and gas. All right, but make sure you have down some good ways to tell them apart from each other. All right, so solid has a definite shape. All right, I mean, if you think about something, it's solid. You can hold it in your hand and you can't change it. All right, so like at least not without like some serious tools and pressure. So like, you know, your computer that you're working at right now is a solid. The desk you might be sitting at, the chair you're probably in. All right, solids have, so their kind of telltale things are definite shape and compressible. All right, so computer, desks, chairs, trees, walls, all sorts of different things. Liquids, however, their shape is not definite. They can change shape, but they are going to take on the shape of whatever container they're in. All right, but again, so it takes on the shape of the container, but again, not compressible. All right, and we'll talk about what compressible means in a second. But what are some liquids that you know of? One that usually pops up early on: water, soda, juice. All right, all sorts of different liquid flowing type things. Might say mercury. All right. Gases, on the other hand, they have no shape at all. They will fill up whatever space they are in, and they will not stay confined to a container. All right, so like gas in the room that you're in is filling up all different corners of the room. All right, and you know, like if you had a balloon and you pop it, the gas leaves the balloon and spreads out through the room. The unique thing to gases, aside from its ability to kind of just fill and go anywhere, is that it is compressible. Right? And what that means is you can force, or you can squish, the same amount into a smaller space. That's what is meant by compressible. Alright. Doesn't have an infinite capacity for this, but like say you have a balloon. You can make the balloon get tinier. I mean, eventually the balloon will pop. But you can squish the balloon and force the gas molecules into a smaller space. All right? With the right equipment and a container that's strong enough, you could take all of the air that is in the room you're in right now and put it into like a 1 by 1 foot container. All right, so it's compressible. You can take that same amount and squish it into a smaller space. So air is a really good example of gases. If you think about what you breathe in and out, oxygen, CO2, ammonia is a gas, lots of examples. So here's some practice for you. Metal mercury flows across a table and takes the shape of any container it is placed in, but will not necessarily fill the container. What state is mercury in at room temperature? All right, so you can see that it takes on the shape of the container that it's in. All right, so it doesn't have a definite shape, so I think we can knock out solid. All right, but it doesn't necessarily have to fill the container, which means it is confined. It does have a shape. So that's going to be our liquid. All right, and then the next one, what is the defining characteristic of a solid? So if you need some more time, think that one through. But solids do not fill up all open space. That's our gases. They are not compressible. Again, that's our gases. They have a definite shape, so A is your correct response there. energy, on the other hand, is not a physical thing. You don't see it, touch it, but you know it's there because when energy is applied to matter, a change occurs. All right, so there's all sorts of different kinds of energies you can run into. One that you're probably most familiar with is going to be thermal energy. All right, if something heats up or cools down, changes temperature, that's a transfer of thermal energy. You're probably also familiar with energy being given off as light, so like burning a candle, providing light, that's energy. Energy also can change the makeup of a chemical substance, and we call that chemical energy. All right, most energy changes actually combine several of these, but in this class we're going to focus a lot on thermal energy. So the other thing you want to focus in on is the two different types of changes that energy can cause. All right, so energy can cause what we define as a physical change. So the energy changes the matter, but the matter's molecular structure remains the same. All right, so you can, you start with water, you heat it up, cool it down, something like that. You change the water, like maybe you evaporate it by adding heat to it, but you still have water molecules, right? Whereas a chemical change, you're going to apply energy. That energy changes the matter, and the matter's molecular structure, typo here, changes. All right, so say you take electrical energy, put it in water, and you split the water into hydrogen and oxygen. All right, so now you no longer have H2O, you have H2 and O2. All right, so let's apply that to a question. You've got a tub of water is placed in a small room and heat is removed from that room. What is likely to occur? All right, so what do you think happens when you remove heat from water? Right, if you're removing the heat, that means you're cooling it down. So hopefully you are saying B, the water will freeze. And another kind of bonus thought here, is that a physical or a chemical change? Frozen water is still water, so that's a physical change.